Alright, so this one says factor the polynomial using factor by grouping. I'm not solving, I'm just factoring. Let's get the basics of factoring by grouping down first. You'll remember it from rainbow method. We're going to group the first two and group the second two. And then what we're going to do is we're going to pull out a GCF. So if I pull out a GCF from the first group, I can take out a 2 for my number because 2 and 4 are both divisible by 2. And I can take out an x squared as well because they both have an x squared to give. What I'm left with is x, because 2 divided by 2, it's gone, it cancels out, I'm left with 1 basically. And then x cubed divided by x squared gives me x. Do the same over here, I'm going to be left with 2 because the x squareds would go away. 4 divided by 2 is 2. Okay, let's get to the next one. Here, I can take out a 3 from my number, and there's no x to give from the 6, this term right here, so I can only take out 3. And then I'm left with x minus 2. I'm almost done. I take my 2x squared plus 3, that's one factor, and my x minus 2, that's another factor. And if I were to solve, I would set each factor equal to 0 and solve, but we're not asked to do so here, we're just asked to factor, so that's that. Pretty awesome. Keep an eye on the term that has the squared part. Usually with these problems you're going to have something that's squared, and in that factor you might be able to actually factor even more. We call those bonus questions, you know, when we get extra math for what we already paid for. That's pretty cool. Let's try this one here. This one says find the zeros of the function using factor by grouping. So I'm going to go ahead and group the first two and the next two. And I like to put a little plus between these to know that it's not multiplication yet. Okay, so I'm going to take out my GCF of the first one, which looks like it's going to be 4 because 20 and 8 are divisible by 4, x squared. And I'm left with 2x plus 5. The next one, it's got a negative and a negative, so I'm going to take out a negative 1, and I'm left with 2x plus 5. You will notice that these two factors here, those two parts right there and there, are the same. They should be. What's left over when we take out the GCF should be the same. Or you made a mistake, or you didn't take out the actual GCF. So now I'm left with 4x squared minus 1 and 2x plus 5. But we're not done quite yet. We can actually factor this left one down a bit more. And since we're solving, we can either go right ahead and set this equal to 0 and solve, or we can continue factoring. I'm just going to continue factoring right now so we can work on difference of squares, which is what this is. So when you think about it in your head, 4, square root of 4 is 2, square root of x squared is x, and the square root of 1 is 1. So what I'm going to have is 2x plus 1 and 2x minus 1. That's what this guy is right here, broken down into its two factors. I still have the 2x plus 5. And remember, this is like an f of x equals still. I just haven't been writing it down. So it still equals that. Well, how do I find my zeros? Well, when we were factoring in the past, we would just set each factor equal to 0, and that's exactly what we'll do now. So I can take 2x plus 1 equal to 0, 2x minus 1 equals 0, and 2x plus 5 equals 0. I solve for each one. I get x equals negative 1/2. Here I get x equals positive 1/2. And here I get x equals negative 5/2. And keep in mind when we're writing our zeros, and I'm going to give its own little space right over in here. When we're writing zeros, we write them as ordered pairs. So I'm going to have negative 1/2, 0, 1/2, 0, and negative 5 over 2, 0. Those would be my 3 zeros that I'd have for this cubic function. And notice how it's a cubic function and it has 3 zeros? Yes, that's always going to happen. It's called the fundamental theorem of algebra. You're going to get 3 solutions, 3 zeros, when you have a cubic function. Now, they might not always be different solutions. You know, for example, when you have a multiplicity of 2, you have 2 of the same solution, but it's still 2 solutions plus then another one, so you still would get the 3 solutions even if there was a multiplicity of 2 somewhere. This one, we have 3 totally different solutions. Whoa! Alrighty, awesome.